Your objective for lesson 6 is I will interpret measurement data from various line plots. So we're going to be looking at line plots today, and we're going to be looking at different data from where people have measured objects and then put them on a line plot. So we're going to be looking at this paper right here on the screen, this rectangle, for the concept development and going over some different questions. This right here is a line plot. A line plot is where you see a number line, and there's usually some numbers that are plotted on the line, and then you have X's, and it's really important to pay attention to what the X's are on a line plot, so that way you know how to read a line plot. Eventually, you're going to be making your own line plot based on measurement data as well. So it's really important that you pay attention to how a line plot works, so that way whenever it's time for you to make your line plot, you understand how to do it. So some of the questions that you're going to be writing answers to on your paper are on the screen. So make sure that you have your piece of paper ready for this concept development in your binder. It says, what does the number 1 on this line plot represent? So we're looking right here. And you see underneath all of these numbers, it's kind of labeled like a bar graph was, but this just says hours. So that must mean that this 1, 1.5, 2, 2.5, 3, 3.5, and 4 mean hours. So I'm assuming right here that the 1 is standing for 1 hour. What does the 1.5 represent on the line plot? I want you to go ahead and write that on your paper. It's kind of like what we just did when we looked at the number 1, but now we're looking at the 1.5. What does the 1.5 represent on this line plot? Write that on your paper and push play. Okay, so you should have had that it was 1.5 hours. So if we kept going, we would say that this was 2 hours, this is 2.5 hours, 3 hours, 3.5 hours, and then 4 hours on the line plot. And the way we figured it out is just by looking at the label. The next question says, what if the label on our line plot was people instead of hours? Could we have fractions? If you're thinking about that, if I have a number 1.5, and it's supposed to stand for people, you can't have a 1.5 people. There's no such thing as that, so that's why it's really important that you're labeling line plots correctly to where they make sense. So when we use fractions on the line plot, we need to make sure that it makes sense for the units to be given as fractions. So it makes sense to use fractions whenever you're working with hours, because we know that there can be half an hour whenever we're working with time. Okay, so we're still looking at the same line plot. We can show measurements on a line plot with fractions. How is this line plot like a bar graph? And the way that it's like a bar graph is because normally on a bar graph we would have always something labeled on the bottom part of the bar graph, and then our bars would be going up. So for this 1 hour you see 3 X's, and when I look down here I'm looking that an X is 1 person. So these 3 X's must mean that there were 3 people that spent 1 hour outside over the weekend, because the title for our line plot says time spent outside over the weekend. So if I were saying that this was a bar graph and this was actually a bar right here over the 1, then I would look at the other scale on that bar graph and see what the bar went up to, and it would probably go up to 3 on the bar graph. So a line plot and a bar graph are similar in ways, and then not similar in other ways. So the next question that you're going to need to answer on your piece of paper is, which amount of time spent outside has the most X's? What amount of time spent outside has the most X's? I want you to write that time on your paper and push play when you're ready to check it. Okay, so the amount of time where most people were outside over the weekend was 2 hours, because you can see here that it has more X's than any other hour. Okay, so we can say that 2 hours was the most frequent or common amount of time spent outside because it has the most X's. What's the second most frequent amount of time spent outside? So other than 2 hours, what's the next amount of time that was spent outside where it has the most X's than other ones except for 2 hours. So get that time written on your paper and push play when you're ready to check it. Okay, so the next time would have been 1.5 hours because you can see that it has 4 x's, which is just one less than the x's that were on the 2 hours. So what does each x on the line plot represent? We went over that on the last slide. We know that each x represents one person. So how many people spent 2.5 hours outside? So you're looking at 2.5 hours and looking at the x's. So I want you to write that answer on your paper for how many people spent 2.5 hours outside. Just play when you're ready to check it. Okay, so there are 4 people that spent 2.5 hours outside because there's 4 x's right above the 2.5 hours. Now we're going to practice, you're going to write your own statement about this line plot that could be true. And I put an example up there so that way you had an idea of how to do it. But my example was there was only one person that spent 4 hours outside. Because whenever I look at 4 hours on the line plot, I see 1x. So that tells me that that statement is true based on what the line plot is showing. So now on your piece of paper, it's not a question that you're writing, it's a statement. So write down a sentence about this line plot, just one statement that could be true. And I know that it's true because I could check it by looking at the line plot. So I want you to push pause and write down a statement, and I'm going to be looking at that statement whenever you bring me your binder to check your exit ticket. When you have that written, you may push play. Now you need to have out your problem set. You need to push pause to get that ready. You can do that now. Okay, so we're going to be looking at some line plots again and answering some questions just like we did in the concept development. And I hope you've seen that line plots are easy for the most part. You just really have to pay attention to the labels and what the X's represent and really pay attention to what questions are asking you. So for this line plot, it says up at number 1, Coach Harris measures the heights of the children on his 3rd grade basketball team in inches. The heights are shown on the line plot below. So you see that the title for the line plot is Heights of Children on the 3rd grade basketball team. The label underneath all of the numbers on the line plot says height in inches. And then we see that an X on the line plot represents one child. So we're working with the bigger numbers because heights of 3rd graders are not going to be in the single digits. They're going to be probably in the 40s or 50s. So we're going to start with question A, and it says, how many children are on the team, and how do you know? So the way that we figure out how many children are on the team is just by looking at how many X's are on the line plot, because if he measured all of the kids on the basketball team, then all of those measurements would be on this line plot. So you need to count all of the X's on the line plot so we know how many children are on the basketball team, and then we need to write down how did we know that was the number of children that were on the basketball team. So I want you to push pause to get A answered, and then push play when you're ready to check it. Okay, so you should have counted that there were 15 children on the team, and you should have answered that you know that because you counted the X's on the line plot since each X represents one child. Now we're going to move on to question B. It says, how many children are less than 53 inches tall? So we need to find the 53 inches, but you're not going to count the X's that are on 53 inches because it specifically says less than 53. So that means that we're going to look at 52.5 inches, 52 inches, 51.5 inches, and then 51 inches. So I see that there's 1, 2, 3, 4, 5, 6 X's that are all below 53 inches. So that tells me that there are 6 children that are less than 53 inches tall. Okay, so now we're ready for question C. It says, Coach Harris says that the most common height for the children on his team is 53.5 inches. Is he right? And explain your answer. So the first thing that we need to do is look at 53.5 inches and see how many x's are above 53.5 inches, because that is going to tell me how many children are 53.5 inches tall. So when you're looking at 53.5 inches on the line plot, I see 3 x's. But when you're looking at the other inches on the line plot, I also see that 52 inches has 3 x's as well. So that tells me that there are 3 students that measured 52 inches, and there were 3 students that measured 53.5 inches. There's no other inch mark on the line plot that has more than 3 x's. So is Coach Harris right? No, he is not right, because there are 3 students that are 52, and 53.5 inches tall. 53.5 did not have the most. If there were no other x's, or if there were no other inches that had 3 x's, then Coach Harris would be right. But since 53.5 and 52 had the same amount of x's, then both of those heights had the most children. Now, question D says, Coach Harris says that the player who does the tip-off in the beginning of the game has to be at least 54 inches tall. How many children could do the tip-off? So that's like a basketball game whenever 2 players are facing each other and one of them is trying to get the ball to their team, and you got to jump up and hit it. So he wants somebody who's pretty tall to be able to do that, and they have to be at least 54 inches. So that means that they have to be 54 inches or taller. So we're going to actually be looking at the 54 inches. It didn't say they had to be taller than 54 inches. So when I look at 54, I'm going to be going up to 54.5, and I'm also going to be going to 55. I'm not going to go back to 53 or 52 or 51, because that's going to be less than 54 inches. So when I count all of the x's between 54 inches and 55 inches, I see that there's 1, 2, 3, 4 x's. So that tells me that the answer for this question is there are 4 children that could do the tip-off. And now we're going to be ready to move on to the next part of the problem set. We've got another line plot. I'm probably going to let you do more of this one on your own, since we just did the whole front page together. So we need to look at what this line plot is about. We need to look at the labels, and we need to know what the X's represent. So this says Miss Vernier's class is studying worms. The lengths of the worms in inches are shown in the line plot below. So all of these numbers that you see down here on the bottom of the line plot, that's going to be the length in inches. We know that each X is representing 1 worm, and the title of the line plot is the length of the worms. So our first question that we see is, how many worms did the class measure, and how do you know? So this is just like the one that we just answered about the height of the basketball players. And all you have to do for part A is just start counting all of the X's, because we know when we add all of the X's together, that's going to tell us how many worms that were measured. So I want you to go ahead and count the X's and answer both parts of question A, and when you're ready to check it, you can push play. Okay, so you should have answered it by saying that the class measured 30 worms, and you know that because you counted each X on the line plot, and we know that each X represents 1 worm. So question B says, Kara says that there are more worms 3 3/4 inches long than there are worms that are 3 2/4 and 4 1/4 inches long combined. Is she right? Explain your answer. So this is one of those 2 steps problems that we did back when we were working with the bar graphs, and you see this word combined. So that means that you're going to have to combine 2 of these measurements and combine the x's, and then we have to subtract that from 3 3/4 to see if she's actually correct. So we need to look at the measurements for 3 2/4. So we're going to be looking right here. Well, let me get my different circle. 3 2/4, and then we're also going to be looking at 4 1/4. So I know that this has 4x's and this has 4x's, so I know that those two x's combined, or those two measurements combined, give me 8 worms total. And now I'm going to be looking at 3 and 3/4, and I see that 3 and 3/4 have 6 x's, so that means that there's 6 worms that measure 3 and 3/4 inches long. So looking back at the question, it said that Kara said that there are more worms that are 3 and 3/4 inches long than there were for 4 and 1/4 and 3 and 2/4 combined. Well, we know that when we combine these two, that there was a total of 8 worms, and then 3 and 3/4 has 6 worms. So Kara is actually not correct, because 3 and 3/4 only has 6 worms, and when you combine 3 and 2/4 and 4 and 1/4, you have 8 worms. So that's pretty much going to be the explanation that we're going to be putting for our answer. So there's two different parts to this question. No, she is not right, because when you combine, if I can spell correctly, when you combine 3 and 2/4 and 4 and 1/4, you get 8 worms, and 3 and 3/4 has only 6 worms. So that's going to be the explanation, because we just said how we combined it and then compared that with 3 and 3/4 inches. So now we're going to be ready to move on to question C. It says, Madeline finds a worm hiding under a leaf. She measures it, and it is 4 and 3/4 inches long. Plot the length of the worm on the line plot. So this means that you're not going to be writing anything here underneath part C, that you're actually going to go up to the line plot and you're going to put an X for where this new worm would go. So if the new worm is 4 and 3/4 inches, all you got to do is find 4 and 3/4, and we can see right here that it does not have an X, so this one is now going to have an X on it for this new worm that she found. So now, instead of having a total of 30 worms, now that we've added an X, now there's a total of 31 worms. Okay, so you're ready for the exit ticket. You're going to take a look at the line plot, and you're going to answer questions just like we did for the concept development and the problem set. So whenever you're finished with that, you may bring it to me so we can check it.